Hello, hello. Hi, Maurice.
Hello,
Hope you are doing well. Do I pronounce your name correctly?
my name is Maurice de Beyer.
Okay, Maurice. Okay, fine.
Yeah, my first name is French, so if you try to pronounce it with a French accent, it's always good.
Okay, I get the point. Great, great. So I think nobody else will join us, but so I think we can start in this case.
Okay, so you just want me to run through the presentation as
Yes, some kind of a demo version, a session just to share after also with other program committee members. So, okay,
yeah, that sounds good.
good.
So I hope my PC is not gonna hang because I've been having. So I'm hoping that's not gonna be an issue. Let me share my screen. Ew, that looks really.
Yeah, recursion in action.
Yeah. So let's minimize this and get the presentation. So you can see my presentation now.
Yeah, I can see PowerPoint.
Okay, excellent. So good evening and welcome to this session on building high performance web applications. So what are we going to talk about this evening? Well, first of all, we're going to take a look at what fast is, because just saying something is fast is actually a little bit of an oversimplification. Then I'm going to show you some tooling which you can use. It's just a sample of tooling I use. There is much more, so don't take this as the set of tooling you should use, but more of a guidance. This is the kind of tooling you need to look for and some of the tooling you could potentially use. And then I'm going to show you a number of techniques which help speed up applications a lot, like code splitting, server-side rendering, etc. So who am I? My name is Maurice de Beyer, also known as the problem solver. I'm an independent developer and instructor. And as you might notice from the logo, I'm a Microsoft MVP, so most valuable professional. Now, I'm an Azure MVP, and given that this is about web, you might think I'm going to show you all sorts of cool tricks how to use Azure to make things faster. Uh, if that's what you're looking for, I'm afraid I'm going to disappoint you because I'm not going to talk about Azure at all. I do have a demo application that is hosted on Azure, but Azure is just the host and it's not important otherwise. So why is Azure not important, or most of the hosting for that matter? Well, every time you go from a browser to a web server, you're incurring latency, and latency could be between a few hundred milliseconds to seconds, or even more if you're in a bad spot, like if you're over a satellite connection. So as soon as you do anything that has to hit the server and return from the server to get any feedback to the user, it's never going to be fast. So instead, everything I'm going to show you is going to run in the browser and respond as fast as possible with as minimal I/O to the server as possible. But first of all, why do you want to make fast web applications? Because to be honest, it's kind of cool if your application is fast, but you really want more than just coolness. Like if I go to my manager and say, hey, I've got this really cool plan to make it twice as fast, it's going to cost you about 10,000 euros. He's going to have a good laugh and tell me to go away and get back to do some productive work. Well, I've got two figures which kind of show you that this is important. The first is from bol.com, which is the biggest online retailer in the Netherlands. And they've got a good website. They've got a pretty good smartphone tablet app. But in July of 2016, so a little over a year ago, their website traffic was about 40% for mobile devices. So I'm not talking about smartphone apps, any of that. It's the website traffic. I haven't had any decent recent figures, but I've understood from some people there that it's currently already above 50%. So lots of people are hitting their website using phones, tablets, not just PCs. So okay, that helps because they're less powerful. So if it's faster, that's nice, but that still doesn't pay for the bills. Well, another figure from Amazon helps there. They've done lots of tests, and they're probably the biggest online retailer in the world. And they tested and determined that if they add 100 milliseconds of latency to their network traffic, they actually lose 1% of their sales. So just 100 milliseconds, 1/10 of a second, costs them 1% of sales. Now, I'm not sure how much Amazon grosses, but that's a lot of money. So it pays to be faster. Now, you might not be doing online retailing, so it might not be as immediately obvious how much things cost or don't cost. But even if you're doing an in-house application and users are using it for their daily work and they really can't go anywhere else, they have to use it, they'll still be happier and more productive if the application is fast. It's just not as obvious and it's not as easy to put a number on there. So I talked about fast, but what is fast? And it turns out that's a little difficult. If you look at this plane, that's the Blackbird, the SR-71. That's fast. It does about 4.5 times the speed of sound. It was developed during the Cold War, and apparently it flew over Russia quite often back then. And the Russians tried to shoot it down, but from the official stories, it was so fast it could outrun a missile. So in absolute speed terms, it's definitely very fast. But you can see from the windows that it doesn't have much of a crew compartment. In fact, it's a two-seater. In fact, this is a training version, but the actual fighter was, or reconnaissance aircraft was actually also a two-seater. So there was a pilot and a navigator and nothing else. Now, if I wanted to take, say, 100 of my closest friends on a trip from Amsterdam to Moscow, doing it in a plane like this would not be very efficient. Yes, it would get there immediately or extremely fast, but the pilot could only take one passenger. So it would have to turn around, do another round trip and another before the 100 people actually got to Moscow. So just using a regular 747, which flies less than the speed of sound, so less than a quarter of the speed of this plane, would actually get all the people there faster. So the problem with speed is it depends. What's going to be incredibly fast in one use case is not going to be fast in another use case. Absolute speed is nice, but that's not the most important. It has to achieve a goal. So keep that in mind when you tune your application and make things faster. It actually has to, well, achieve a meaningful goal, not just pure raw speed for the sake of raw speed. Now I've got a sample application here. If you click this link, bit.ly/fast apps, you'll come to an application, and that's hopefully pretty fast. It should be. I've tuned it in quite a number of ways. And I'm going to show you some of the tricks I actually used to do that. So the first thing about performance is, as Paul Lewis very elegantly put it, performance is the art of avoiding work, and whenever you have to do something, make it as efficient as possible. Which really describes it well. Like if you can avoid doing something, it's the fastest you can get. I like to add one more thing to that. Easier to make an app not slow than to speed up a slow app. Like if you build an app and you keep working on it, adding things, and it becomes sluggish and slow, it's going to be incredibly hard, if not impossible, to tune it and speed it up. It's much easier to start with this from the start, evaluate everything you do, every step you take, and avoid making it slow. That's really the only practical way of achieving it. Trying to do it after the fact is almost impossible, and in most cases you'll get some speed up, but not really any significant ones. So how do we measure speed? Well, in the good old days of the web, we often used an event in the browser called DOM content loaded. DOM content loaded kind of meant that the browser had loaded the HTML from the server, it had parsed it and had rendered it. It would have come across different URLs for maybe style sheets, maybe scripts, JavaScript, stuff like that. It would have downloaded those and executed those. So by the time this event fired, you would have a lot of UI visible, and most of it would actually work. And if not, it would work pretty soon. Nowadays, that's not all that useful for more modern web applications. They tend to run or load a minimal set of markup, then execute a lot of JavaScript to actually render the application. So if you're using Angular or React or one of those frameworks, the DOM content loaded fires and there's actually no UI to be seen yet. So it's not all that useful for most sites. So a more modern approach is to measure the first meaningful paint, and I'll show you some examples of that later. But first meaningful paint kind of shows up when the browser actually shows something. So you might load a page, and whether that actually contains the markup or React or Angular renders the markup, this is the first markup the user actually sees. And measuring that is relatively easy and is a lot more meaningful these days. But there is actually a better one, which is called time to interactive. This is something Twitter kind of pioneered. I'm not sure if they were the first one to actually do it, but they were the first to make it popular. And their mantra was, how long does it take to load up the Twitter website and be able to type in a tweet and press enter to show it to the rest of the world? So the website would have been loaded, it would have shown you whatever was supposed to be shown. It would be interactive, reacting to events and inputs. This is really the best measure at the moment because showing things and being active, interactive is too. Of course, first meaningful paint still is very useful and actually relatively easy to measure for browser tooling. Time to interactive is slightly harder to measure with asynchronous JavaScript, etc. So it's not as easy, but it is a very good metric. Turns out there is more though to speed. It's not just how fast your application is. If you look at mobile devices like Android or iPhones, they run on a battery and those batteries tend to run out relatively soon. So making an application very fast, but it's completely drains the battery in an hour is not going to make users very happy or productive. So you want to be conservative of battery usage. Turns out this is the harder part. There is a lot of tooling to help you tune CSS, JavaScript, and network I/O, etc. There is very little which will help you tune battery usage. The best guidance I can give you here is avoid lots of polling to the server, because on a mobile device, every time you activate the 4G chip, which sends out a radio signal, you actually start using a lot more power than when it was passive. So if you do that frequently, you're polling every minute for some change on the server, you're gonna eat a lot of battery life there. So be careful with that. And of course, the same is true if you keep connections open, maybe do something like Signalar or Socket.io style communication. So some of the tooling I use frequently, and like I mentioned, this is by no means the only tooling you can use, but there is a lot of very useful stuff here, and there are a lot of similar tools which could replace the tools I use and get you the same goal. So I tend to use Chrome a lot, and the Chrome timeline actually gives you a lot of information. Now let me show you an example. Let me switch to a browser, and I've got my own website up here, and if I press F12, I'll get into the debugger, and I can go into, where is it? No? Performance here. And if I press the refresh button there, it will actually reload the page. It will take CPU or a snapshot of what's happening during that time, and it will actually show you. So that's a really easy thing to get started with. Now you'll see lots of different colors here, and all the yellow you see, let me resize this a bit so it's a little more important. All the yellow here like this is evaluating JavaScript. Now my website is actually a pretty old site and running ASP.NET MVC, and I just happen to know there is actually very little JavaScript on this page. There is some, but not much. If you look at this, there is actually a lot of JavaScript going on, and it takes quite a bit of time. So this whole page took what is it up to here? So can I see? So that's about 1.3 seconds to load. So where did this all come from? Well, let me open an anonymous window, if I can. Uh, with any luck, it opens. There it is. Open up my site again, and I'll do exactly the same. Go to the tooling, start a profile, and see what it looks like now. So you see it looks completely different. That's causing the difference between the two profiles. Where was my other profile? Here. So it turns out the Chrome tooling here actually includes all of the JavaScript plugins, or the Chrome plugins, I should say, you've got enabled. As you can see from the top bar here, I've got quite a few enabled. So these do tend to clutter all your profiling in Chrome, and you should be careful with that. My general advice is, if you can get away with an anonymous window, use an anonymous window, because by default plugins are disabled there, so you'll get a much better view of your actual page. Or if you need some plugins, disable all the others and have as few plugins running as possible. It will give you a much better result. But this is really nice. You see a lot of information. You see what executed here. You can see that at this point, so we're at well, about little over 3/4 of a second. We actually see the page. You can see that from the film strip here. You can see what was painted at the time. So lots of information there. There's also two other settings here, which you should always use if you're working for mobile. So by default, there is this network throttling. That's disabled, no throttling whatsoever, so you get whatever connection speed you have. I typically set this to fast 3G when I'm developing for mobile applications. Below that, there is a CPU throttling. I tend to set that to either a 5 or a 10 times slowdown. 10 times is a little more realistic. Why these? Well, I'm connected over Wi-Fi to pretty fast internet connection. The average phone will not be. It will use 4G, 3G. So fast 3G connection will give you a pretty decent indication of what a mobile user actually uses. The same with a fast laptop. Lot faster than the average phone or tablet. So by slowing down the CPU, I'm going to get much closer resemblance of what mobile experiences. So this is pretty much what I enable every time when I'm working on a mobile application. And if I is longer, so we're at 10 seconds already. Now we've got our first meaningful paint. So that was around the 10-second mark instead of 3/4 of a second before. It's still acting, not quite sure what, but it's almost finished. So there we see. So we saw it was actually 11 seconds, the first meaningful paint, and the whole page was loaded after seconds right here. So you can see that that affects things a lot. Which I use a lot, and this screen shaded because the audits page actually looks completely different now, is Lighthouse. What used to be the audits tab like this is now actually a Lighthouse, which used to be a plugin. It actually activates, so you need to close down the developer tools. I could say generate report here. Well, this plugin is out of date. You shouldn't use this anymore. Instead, go to the audits tab here and hit reload, and again it will generate a complete audit of my page and tell me what's the problem. And I'm actually in the wrong page here. I want to use this one. I was actually looking at the coverage profile instead of the Lighthouse audit. So this again will load my page. It will that I see at least the top of a mobile device in screen. It will try to simulate what happens if there is no network connection, and a lot of will give me a slow. It's still busy. The reason is that Lighthouse is very much in favor of using a service worker. I'll come back to those later, but they're a great way to things in the browser. It's something I haven't enabled on this page, so as a result, it's not gonna load all that fast. So you can see in 27 is quite decent. Best practices is reasonable. Now, if I go to my demo app, Bitly Fast Apps, and delete this and perform the same audit here, it should give me a much better score. This is a progressive web app which uses the service workers, and it's going to give me a perfect score, but it should be quite good, especially on the second load. Now, I didn't reload it this time. It actually comes up with a translate. Almost done now. There it is. So you can see I'm scoring 91 out of 100 for a progressive web app, 92 out of 100 for performance, etc. But still, there is stuff to be done. And down, if I scroll down, you can actually see some warnings here. So you can see there is a background, foreground color don't have a sufficient contrast ratio, which I think is because of the top toolbar, which, by the way, is a standard Bootstrap toolbar. There is some other stuff like the HTML element needs a language attribute, that needs to be some meta tags, should be using HTTP2 on the server. In this case, I'm not using HTTP 1.1. So there's certainly still things that could be improved here. Highly recommended tool. So another tool I use, which is not standard in Chrome, but a plugin, is Wislow. Wislow is actually very similar to what the old audits in Chrome will show you, but it's different. They look at different things. It's the same style, but they look at different things. They come up with different suggestions for specific issues they run into. And it actually turns out they are very much complementary. Some things Chrome will trigger and tell you about, other things Wislow, and if you fix all of them, it will benefit everything. There is nothing there which says where one browser will penalize you for doing something which the other way will actually make it faster. So I'm not actually going to run this now, but it's really easy to use. One drawback both of these tools have is that they actually run in your browser. So you're testing on your local machine, your local browser, and developer browsers and machines tend to be relatively fast. although browsers also tend to have a large number of plugins. But how your application is going to work on the internet from different locations with different connections, etc., that's a lot harder. And this site, web page test, will actually help a lot there. So if I grab my URL here and I go web page test, there it is. I can enter a URL, go and test that page. Now with test location, I can check for based on different locations and actually different devices. Now these devices are mostly US based. Locations are a little more worldwide. As far as I know, there is no location in Russia, so you can't test from a browser in Moscow. But I could, for instance, take Amsterdam or let's say Frankfurt. And then depending on the location, you can actually use different browsers to test. And if you go to advanced settings, you can actually go and do much more. What kind of connection do I want? Well, let's use fast mobile 3G or say a cable connection or maybe a really slow edge connection. That's for now, let's just leave it at cable. You can test things like what happens if JavaScript is disabled or things like that. Emulate different browsers inside of Chrome. At least in this case, I'm using Chrome, so I've got these options. Use basic authentication and lots more. I'm not sure if I'm going to get a response. Basically, I'm using the free version of web page test, so everything is put in a queue. And I'm actually at the front of the queue, so this is probably not going to take too long. But if you're taking a popular location, especially one of the mobile devices tends to be popular, and you're at the wrong time of day, this could take a long time. You might have to wait half an hour. There is a paid version of this, which is a lot faster. But here we can actually see what happens. So we see the Chrome waterfall of all the HTTP requests finishing occur, and it actually runs it multiple times. So I get lots of details here about what happens. Of course, you can run this as often as you want from as many sites as you want. So this is actually a lot easier in that regard. So if you just want to get started using this simple testing, is actually easy. Put in the URL, kind of suggest what you want. Do you want mobile emerging markets, mobile faster 3G or desktop? And then say potentially also a lighthouse audit. So let's do mobile 3G and start the test again. Not sure. Oh, it's actually testing directly, so I guess I'm really lucky this time. And it's going to give me a similar report as I just had, only different browser, so different capabilities. So you kind of get different statistics here. So we'll come back to this in a minute when it's finished. So here are a couple of the settings which I just went through. The page you load. So this was a screenshot from the original Lighthouse, which I should remove from the presentation because the plugin is really no longer used. So my test was actually completed already. You kind of see the same results, and you can response. Oh, it actually downloaded the timeline JSON. I wanted to view it, not download it. So it looks very much like the Chrome DevTools because it really is the Chrome DevTools output from a remote site. But it's still interactive, so you can still work with it very much the same way as you could locally. That was some of the tooling. I'm actually going to show a bit more tooling later on, as I'm going to show you some other stuff, but that's the most important of the tooling I use. Now remember the quote from Paul Lewis from Performance is the art of avoiding as much as you can. Well, this is the perfect example of that. I've got a bit of JavaScript here, ECMAScript 2015 style, where I'm doing the ECMAScript import, and I'm importing from Lodash, a popular library with lots of functional utilities there, and then for each, like the name suggests, loops over an array, and it executes that fat arrow function for each item there. Now this is relatively simple and it works. Let me start up code so you can actually see the code. Now it's freezing up again. If we look at the dist folder, there is one bundle there, and let's create that. Why did it freeze up now? So we'll create it in the way which was just shown on the screen. So I'm using underscore dot for each, which will run Webpack. We'll use Webpack to bundle this up, and we'll take a look at the size of the bundle. So my bundle size is 544,243 bytes. Quite a lot, but then it includes all of Lodash. Now let me change the syntax slightly first and run it so we can see the difference, and then I'll explain what I actually did. Back again. Bundle size. Now we've got a bundle which is 33K, so 33,042 bytes. Compare that to more than 500K before. So what just happened? Well, with this first import underscore from Lodash, I was importing everything from Lodash, creating one big object with all the Lodash functions, and then using only the for each function from that. With the second syntax, I'm saying, well, import just the for each function from Lodash, and I actually have to say from Lodash slash for each, only that function plus what it depends on. So we could see the output slightly different. The first time we could see that it's included Lodash, Lodash global modules, and it was done. The second time we could see it's included a bunch of functions. Is array like for each, an underscore array each, and a number of things. But all of those were the ones that were actually needed. So my whole bundle is a lot smaller. Now there are a couple of benefits from this. First of all, a smaller bundle means less I/O over the network. 33K loads a lot faster than 500K. But it's not just load time. It's also, once that's loaded, the browser actually has to parse that, tokenize it, and turn it into executable code. That takes time. If you parse 500K of code which you're never going to use, it will still take up time. It's relatively fast, but still it takes time, especially on the mobile device. So if you can avoid doing any of that for code you don't need, you're off much better. So instead of doing it this way, use the second approach. Now remember, you need to import from Lodash slash for each. That's specific to Lodash. Every library that supports this does it slightly different, but with Lodash you actually have to do it if you import curly braces for each curly brace close from Lodash. It will still import for each, the code will run, but it will still include the complete Lodash library. So be slightly careful with that. If you use RxJS, you've got the same kind of issue. The top import RxJS from RxJS, will import everything from the RxJS library, which means almost a megabyte of code. And we're only using the observable from the map and the subscribe there, so there isn't all that much we need. Lots and lots of code downloaded, parsed, but never actually executed. Using the bottom style, import observable from ArcGIS observable, and then importing the operators we actually need. The observable from to create an observable and the operator map to do the mapping. Then you only get what you need and you load a subset of ArcGIS. In this case, I'm not sure how big it will be, but a lot smaller than the real one. So be careful with loading. Another one is code splitting. And code splitting kind of means that you split up the bundle. In this case, I just created one bundle, but you split it up into as many different parts, which you can load asynchronously only when needed. And it turns out that's relatively easy in lots of cases. Let me show you an example. Let me stop this one. Don't need this one anymore. And let's stop code. And let's go to another project. And I'm going to start up code here. And things have become slow. My apologies for that. npm we're going to start. npm start would have done it. So I've got a little Angular 4 application here, which is going to show us some movies. And assuming it starts, there it's going to start up browser. I believe it's port 5000. Oh, this is the application. We'll have to start first. This is localhost port 4200. Bundling. He starts freezing up and becomes really sluggish. Still trying to debug that, but I haven't found the issue yet. Angular is big and it can be slow, but it's not this slow. Not like my machine is very busy. Well, it is now, but wait. Let me explain what's going to happen here. I've got an Angular 4 single page application, and it's we're actually on. But I'm not using splitting. It's actually loading, so now it should navigate to movies. Does it actually navigate? I see the URL change, but I'm not seeing it load data. There it is. Now the thing is, let me go back to the developer tools, network, reload the application so we can see what happens if we switch to the directors. Actually, it's still loading. There it is, it's loaded. Now if I switch to the director view, so all it does is load this directors.json, the data it needs, but all the code was already loaded. Now in this case, they're just 2 pages, no big deal, but there might be lots and lots of different pages which the user is never going to activate. So let's turn this into a split bundle. In Angular actually change the routing. I do not want to refer to these components directly. Get rid of those. Actually, empty out this path. Specify those results. Get rid of those, and these are no longer known, so get rid of those. My application, but if they activate, I can say, well, this is the movies page, specify the path here, and in directors specify this is for the directors URL. Yes, please catch up. Directors. So that's most of it. I need to do one more thing because now there is actually no way these movies or directors module would be loaded. If I go back to my main module, I can actually specify that based on a specific, in this case, movies and directors, it should load specific other modules, but now in non-direct split way. So if I go to the console, there were 4 different chunks. So polyfill, main, styles, vendor, and inline bundles were created. At the bottom, you can see that the last build actually created some more. It also created a 6.chunk.js. So it actually started building more bundles there. And if I go back to the application, and let's refresh it to make sure. See the original. I was expecting to see something here. There it is, it's loading up everything. And once it's done, I'll clear it again. The code for the director's page is not loaded yet. You see the first thing that happens, it actually loads that 7.chunk.js and it loads the page. And for some reason, it's really showing it slow, still in actually showing anything because that would actually be because I had an error. What's the URL here? Directors. I think I've got a typo. Directors doesn't look like a typo. Not sure what I did, but at least
never mind.
yeah, at least we can see that it only tried to load the code when it needed to. Unfortunately, my demo was a bit broken. Sorry about that. Let's
No
close
worries.
this down and stop
It's
this.
JavaScript at least, right?
Yeah, actually TypeScript in this case, but
yeah.
So that's code splitting. That actually works really well. It speeds up your application a lot if you do it at the right level. So highly recommended. Another very useful tool is a source map explorer. If I actually build an application, a bundle, it's kind of hard to see what's exactly in there. Of course, you can open the file, it's JavaScript, but it's really hard to figure out large bundles. Well, there are several tools, and one of them is a source map explorer, which will actually show you exactly what's going on. So I'm not actually going to demo this. It's really easy. You just install it using npm and then run source map explorer, point it at the bundle, and it will show you a graph like this. And in this case, you can actually see at the top, this is a file which is 2.3 megabytes large. And over here you can see that almost 1 MB is actually a compiler.es5.js. So this is an Angular 4 application which is bundled up in the most simple way, which means that the whole compilation is done in the browser, so the whole compiler is shipped to the browser. If you compile an Angular application using the AOT option, the ahead of time compilation, then it actually doesn't need this compiler in the browser. It will automatically drop it, and your whole bundle shrinks from 2.3 to 1.3 megabytes, which is still huge for a JavaScript application. Then there are other techniques which will make it even smaller. So another very useful tool. Um, so another decision you need to make up front is what's the right framework. Just now I was using Angular. And Angular is nice, it's very powerful, but Angular 4 is still kind of large. Like, reputedly, the smallest Angular application you can make is about 50K in size, but that's really a hello world application which doesn't do anything useful. A more realistic Angular application with the Angular modules you're going to load is going to be at least 400 or 500K, so quite large, and that's not counting your code yet. So if you want to load it up on a mobile device, probably not the best of ideas. So instead, you might say, well, I'll go to React. React is a lot smaller, around the 50K size. You'll need some additional libraries which are included with Angular and not with React for network I/O or other things. But you'll probably end up with something like 70 or 70, 75K. Add your own codes, and you'll have an application which is a lot smaller. But it turns out you can do even better. My sample application is not done with React, but with a library called Preact. And let me open up Preact page, preact.js.com. And here you can see it's a fast 3 KB alternative to React with the same. Well, it's slightly exaggerating the truth here. It is 3 KB, but that's gzipped on the wire. If it's not gzipped, React is about 8 KB. Still, that's a fifth of what React is. And it's got a simplified version of the React API. So most of your React code will work unchanged, but some of it is just going to be ignored. And there is actually a Preact compat add-on to Preact, which will add almost all of the React's API back. It's still a lot smaller than React itself and a lot faster. So it's very nice. And that's the one I actually used for my demo application. So that's this one. So let's start up code here. And let's go take a look at this one. npm run dev to run. My window is really slow again, because I finished typing and all I could see was npm. Now it's starting up. For it to start up a browser window and show the application, which is really the same application I was just showing in Angular, but now done using React. Still now leaves quite a bit to improve on. I'm not using code splitting, and I'm not doing some other things which will speed it up a lot. Application loading, and let me close some of these other pages because lots of Chrome windows are going to slow it down as well. And that one will be closed, and this one. Almost the same application, although its UI is slightly broken at the moment. I think I forgot to undo one change. But just like before, we can change between movies and directors. Now, if we're on the movies page, you might notice this is quite a long page. Lots of movies here. I forgot the exact number, but there are quite a few. And let me actually first fix the UI because this is kind of annoying. Where is my style? There. Let's use the original bootstrap instead of the other copy. There it is. That looks better. Still behaves the same way it should. Is it? Yeah. As I was saying, the list of movies is rather long, and like just with a Google search or something like that, people will scroll down a bit, but it's extremely unlikely that people will scroll down all the way and look at all those movies. They might jump to the bottom, but it's quite unlikely they'll look at all of them. So if I would run YSlow on this page, it would actually start complaining about the number of DOM elements there. There are way too many. So a relatively easy way to fix that is to introduce paging. And I've got the movies.js component here, which renders all the movies. And here I can say, well, just take a specific number of movies, don't render them all. So how does it know how many to take? Well, I've initially set that number to 5, so it's just going to display 5 movies now. So a short, much faster loading page. But then I use the scroll event and I kind of track the browser's position. So during the scrolling, I actually update the state and say, well, add some more movies to show. So now if I switch back and I scroll down, you can actually see the scroll bar on the right row. So the further I go, it actually starts adding more movies. Now I'm getting more and more DOM elements as I scroll down, but I only get those when I really need to. So if I switch back to movies and directors, I've only got the top set again. So my whole page loads a lot faster. There's another optimization here. Like if I make my screen smaller this way, I want to resize it, but it doesn't want to cooperate. There it goes. If I make it smaller, the code actually hides the image. But if I look at the network tab, and let's go to the network, and let's just show images, refresh the page. I think I forgot to do a few things. Movie. Oh yeah, this line should have been commented out. A little too busy to prepare everything well. Sorry about that.
No worries, everything fine.
Yeah, it's been really busy here. So now you can see in the UI there is actually no image being shown, but when I scroll down, you can see in the network tab that more and more images are being loaded. So I'm doing network I/O for no good reason. I'm loading images which I'm not displaying. I've got the hidden XS class on this, which means it's a bootstrap class which says if it's a small size screen for mobile devices, just hide this. But it's still being rendered invisibly and it will still trigger the downloads. So instead, I'm checking the actual size. So this parameter is passed in as a prop to this component. So with this parameter in place, and I go back to the top now, no images until I actually make the screen large enough that they are shown. And when I make it smaller and I scroll down, I'm going to load up more movies, but again, none of the images will actually be loaded. So this kind of avoids loading them. So how does that work? Well, like I said, this screen XS size is being pushed in. How do I determine that? Well, I've taken the Bootstrap style, the media query, and put that in here. So that's actually set to this max width. And there is this match media JavaScript API, which you can use to check whether a browser actually matches or doesn't match that media. It also contains an event. So I initially just check, do we match it or not for the first case? And then I set up an event listener that will actually change this property when the screen size changes. So if it becomes wider or smaller, to update the property. This property, or the state I should say, screen access, is then passed on to all the child components here. So they all depend on an input property. So again, this saves a lot of unnecessary bandwidth. Really easy to do with a library like React or Preact, like this. Another important thing is that first paint I mentioned. So let me show you what happens on a really slow network. And I'm kind of going to fake it. I'm not actually going to use a network, but I'm going to say what happens when I disable JavaScript. So I'm going to disable JavaScript here, and I'm going to refresh the page. So that's what the user would see on his device until all the JavaScript really has executed. Well, in this case, obviously, it's never going to execute because I've disabled it. It's kind of like an empty page. Well, the way to make this disappear, this issue, and have the UI appear faster in every case, is to use server-side rendering, which means we're actually going to render the page server-side. But that means that your application has to run on the server, has to do things there, and that might actually be expensive. And you probably would need to run Node.js there, and you might be a .NET shop not wanting to run Node.js on your server. So what I quite often do is actually use an intermediary form, kind of the poor man's server-side rendering. I render the application in my browser. I just grab the output from that, and you can actually do that with plugins in an automated way. And I open the index page, the index.php in this case, and say, well, there is this nav bar at the top. So uncomment this. Now, if I reload the page, at least get some UI. It won't do much. Like I can click on links because they're normal anchor tags, but other than that, it's not going to do anything. Doesn't look very pretty, but at least it's something. The same is for, okay, there are some movies. Now, I can't actually load those movies on the server, but what I can do is create something which approximates that. So I've actually got same kind of UI with lorem ipsum text, but I've added this class here, blurry, which will make it blurry once I've enabled the styling, which kind of look like movies being rendered, but they're not really. And I'm just rendering 3 because on most browser sizes, this will be full screen. So still doesn't look very pretty because of the lack of styling. Well, that's this top part. And I'll show you in a minute how I created this, but let me enable this first. Let's find the top. There it is. Take this page again. Reconnect. Now you can see the blurry effect, like right now, because it stays on screen quite long, you can see there is actually lorem ipsum text there. But with JavaScript re-enabled, it shows up very briefly. If you look, see it actually stays a bit longer on screen than I would have expected. But then is replaced with the actual UI, the actual movies. So how did I do that styling? Well, there is this very useful website, and the image here is actually the link to the website. So this is the critical path CSS generator. You can enter your URL to your page there. On this side, you enter all your CSS, and then once this executes, it will give you the subset of the CSS needed to actually render that first page properly. So that's what I did. I kind of copied all of that CSS it extracted, put it as an inline style. So don't create another CSS file with this, because that would mean another network hop, another requests. Just put it inline in here, and now I'm good to go. So a nice way to speed things up. And of course, in this case, I'm kind of doing it in a manual way, but you can automate this on a CI build where it will automatically inject the last thing. So only rendering the above the fold, that's what I actually already did when I started auto-scrolling those movies. So only render the movies, which you can see, and only add additional content as required. Another thing which is kind of important is latency. Like, there's this really nice website which will tell you about the latency. And let me grab the URL to my page again. Bit.ly fast apps. And go back here, paste it in, click start. This is actually going to load my application from different locations worldwide and tell me about how well the connectivity is. So you can kind of see from this graph that in London it's the fastest. It just takes 94 milliseconds to load. But in Sydney it actually takes 2 seconds, a little over 2 seconds to load. This kind of makes sense to me because this is hosted on an Azure web site in Western Europe, which I happen to know is in Amsterdam. So really good connection to London and relatively fast connection to Frankfurt, but obviously on the other side of the world from Sydney. If you're doing a global application, this is kind of the thing you want to look at. Do all my users get a good response, etc.? You want to use CDNs, content delivery networks, to get your application as close to the user as possible and get as good as performance on this as possible. So another important thing to watch out for. By the way, when I talk about CDNs, CDNs by themselves are a great way to speed things up because things can be faster because they're located closer to a user, but they're not always a silver bullet. I once hosted an application on a CDN because it would be much faster, and then I went on a trip to China and actually used the Google CDN to load up jQuery, and then it turned out that Google and China were not the best of friends, so my application actually loaded a lot faster because they wouldn't just fail the connection, they would just kind of hang on to it for a while. But that's another one of those geopolitical things you have to be careful with. Not technical, still an issue. So conclusion, everyone likes fast web applications, but they're actually good for business. So it's not just nice to have, there is actually good business sense. When you build them, avoid doing as much as you can, and if you have to do it, delay it as much as you can. But anything you can avoid doing at startup means the application starts faster. Everything you don't have to load means it's a little faster. Remember, it's much easier to create a fast application at first than create a slow application and tune it. Do few HTTP requests, use the browser where possible. If there is a native API in the browser, use it over JavaScript. In almost every case, the native API is going to be faster. So with that, I'm at the end of my presentation. Thanks for attending. I hope it's useful. If you've got any questions, feel free to use my Twitter handle at MauriceDB. I'll upload my slides to SlideShare where you can hopefully download them, and I'm sure the organization is going to share them as well. At least I presume they are. Thank you.
Okay, thank you, Maurice. First of all, thanks for your time. Okay, so it took approximately 1 hour, the talk itself. Great, great. Okay, so you covered, cool. So you covered networking, packaging, Angular, also latencies, and the related stuff to web applications, right?
Yes.
Uh-huh. Okay. I have only one thought. I mean, the positioning for .NET developers. I assume that for ASP.NET, even for web forms, it's really interesting for those ones who are more front-end developers. But I have a concern about how to position for the rest of the audience. I mean, because initially on .NET, I think people will assume that it will contain at least some samples from .NET. But here I can see even Node.js, right? I mean, for Angular demos, right?
Yeah, just for the tooling.
Yeah. For the tooling, it's really helpful. Yeah, I see. Okay, great.
But you're right. That's why I explained at the beginning I'm an Azure MVP, but I'm not going to show Azure. My example happens to be hosted on Azure, but that's just a side effect.
It's fair. Yeah. I agree with you. Okay, I think that's cool that we had this with demos because it's much impressive in real life, right? I think the YouTube link we already have in Slack, right?
Yes,
And
the slides I
also there, I think in somewhere in upper right in history. Yes, I can see on the slide share, right?
Yes.
Okay, cool. In this case, I think I don't have much remarks or some kind of because it's really good. And the speech itself, the talk, and let's wait for some feedback from other programming committee members. Okay.
Yes.
Okay, great. In this case, thanks a lot, Maurice, and see you.
If you've got any questions, let me know.
Sure. Thanks a lot. Bye.
Okay. Bye.